Alrighty, let's see. So let's see, am I sharing now? Good. Alrighty. Thank you, Razib. Oh, waiting for my computer. There it is. Yes, I am a business analyst for Greater Horizons, and I've been there for over 3 years. And, you know, we say giving services, but that means donor advised funds. It means employee giving. It means we manage scholarships and related projects like that. So we're a curious blend of the financial and the nonprofit. So I do that. And then I also have a side gig where I do social media for P3 Power BI Consulting. I did consult with them for a year, and just it was an incredible experience. But I know that I myself like to work for one company full time. And then I also like to work for small companies. I prefer to, the company I'm at now is 80 people. So I'm a lot more comfortable at that end than I am at a huge company where I'm just doing the same thing repeatedly. So here's my contact information. Please feel free to contact me. And if you have any questions or you would like more information. So I'm going to talk about business analytics, and that, you know, there's a lot of terms out there. So business analytics, business intelligence, and self-service business intelligence. So business analytics is a traditional term that is all about analyzing historical data, getting a handle on all of the data that has happened and just knowing what it is. That's a huge project, and there is still a lot of opportunity for that. Business intelligence is the evolution of business analytics. It's the same thing. There's more advanced statistical analysis sometimes. There's machine learning. These are all part of the field. And finally, self-service business intelligence. This is the promise. This is kind of an emerging area. So it's a promise of people who use the data being able to quickly find insights from that data without having to go through an IT process that takes 6 months to a year. I remember I was with a company and the business intelligence people kept saying, don't worry about it, don't worry about the cost. And then 9 months later, they said, okay, it's $40,000 a month. And we said, well, okay, we're a big company, but we're just a facilities department. So no, thank you. The outlook for business analytics is pretty good. The US Bureau of Labor and Statistics expects that it's going to grow 11% between now and 2029. The median income is 85,000, and you know, like I can tell you, consulting can pay really, really well, but it's also very intense. So there's that. And the getting into business analytics is pretty straightforward. If you have most people have a bachelor's degree and less than 5 years experience. Whatever you do now, you can get into analytics. Just look at the data around you and you can transition right into analytics. All you have to do is start analyzing that data. The other part of opportunity is that data is everywhere. So all kinds of systems, many systems that businesses use. Every time I think I know all the systems our company of 80 people uses, I find another one. So these are ERP systems, financial systems, contact systems, you know, anything you can imagine. And then the projects that can be done from this are all kinds of things, like analyzing workflows. Someone I knew audited engineers for impossible expenses and was able to catch someone who is stealing millions of dollars, and it was such a big deal that it made the papers. So there's all kinds of things that can be done with data in all fields. So on my presentation, I have a short demo. So there's 3 parts to it. It's getting the data, and then modeling the data, and then the third part is visualizing. So the first part, getting data, this is considered cleaning the data, and it is something that data people can get a little bit cranky about because it does take a lot of time, and it's also can be difficult. Traditionally, this has been done using languages like SQL, but this right here is there's UI tools, user interface tools that are quite powerful these days. So this is Power Query. It's been in Excel since 2010. It's the same tool that's used for Power BI. There's a cloud version, and it's also available in SQL Server. So it's all over the place. And it lets you create a query, get the data, connect to the source, clean the data just by clicking various parts of the ribbon. You can also type some code or fix the code, and it keeps all the steps, and it lets you, and that lets you easily, just like a macro, you can step through it and troubleshoot it. So hopefully it takes a lot of time to analyze, to get that data and to clean it. But hopefully those transitions are reusable. You're analyzing the data already, and you're getting familiar with what that data looks like and what you'll be able to do downstream. Secondly, in my demo, involves creating a model, a semantic model with relationships and formulas. So a model could be as simple as one table with a whole bunch of columns on it, and that's kind of been traditional. And the tools I use, we prefer to have the tables broken up with relationships. Now, if you look at an ERP system, it might have hundreds of tables. You don't want hundreds of tables in a report, in a reporting system. You don't want that in your model because you don't need it, first of all. You need that in order to do the transactions, but you don't need that to analyze the data. You need something simple enough where you can draw out those insights from the model. And so at the top, along the top, I have my lookup tables, the dimensions, calendar, customer, product, and then I have the transactions. And those would include sales and service calls. So a lot of people have done reports where they said, okay, let's see what our best-selling product is. But with this model, I can also factor in the cost of the service calls. And from my sales experience, I can tell you that there are highly profitable items that are just not great. And it's things like this that lets us look at things in a bigger context. The third part, I just wanted to show you this because creating the visuals can be kind of a mystery. Yeah, it's true if you want to do some high-end statistics, things that you see published in newspapers or online. Yeah, to do some really complex visualizations, yeah, you may spend years and you may work really, really hard to get those. But to create simple tables, it's pretty easy. So here we're looking at sales, and we're splitting it apart by country. We're doing that. And we're also looking at sales and putting the date on there and looking at it over time. So we can see seasonality and other things that change with time. All right. So there's some issues in, there are some issues in reporting that I want to talk about. The first is very close to my heart, and it is about self-service business intelligence. I was at a conference a couple of years ago, and it was sponsored by an MBA program. And I asked a few people about self-service BI, and they were all kind of either ignoring it or skeptical of it, or they didn't want to deal with it at all. But in my company, we have a strong data culture. We have built enterprise reports. We've built central data models. The models refresh regularly every 2 hours during the day. They are tested. They are hardened. We know what the data model is. But at the same time, we're also promoting the self-service tools. So for example, and when it comes to self-service, everybody has their own style. Everybody has their own needs based on their job and their personal preferences. So I have a few people that will personalize visuals on key reports. Personalized means they can change the visual, what it is. They can change it from bar chart to line chart or whatever. They can add fields, take fields away. And I have some people that use this to create reports that they use on a monthly basis. And then they save that report as a bookmark. And then when they need it the next time, they just go to it. I have some people who will build their own reports in Power BI Desktop from scratch based on the central data models. They know that the model refreshes and that it's been tested. They do have to be careful that they're not pulling something from the wrong table and there is some risk there, but that's usually handled by common sense. So they are responsible for the reports that they do and just looking at it to make sure that makes sense. The possibility recently opened up of taking central models where you connect to it live, and then you can bring your own data. You can enrich it with other data. So an example of this would be maybe going to the web and getting zip code data and analyzing it that way. That has a lot of promise, but we haven't got into it a whole lot. And lastly, we have a number of people who are using their own data in self-service tools. In the IT department, there's someone who uses Power Query for getting data all the time for various projects. The security person is using it for patch management and other security reports that I don't need to see the raw data on. And our SharePoint administrator is using it to produce reports that enable us to process transactions more quickly and spot bottlenecks in the workflows. And I will say too, I have another person who just wants the static data. She gets the data from a good source, but she wants it to look really great, really sharp because of who she's reporting to. And so she will do that. She'll take Power BI Desktop and she will present it, and then she'll export it to PowerPoint, and then then she takes those slides and puts them into her own slide that is very highly controlled. So there's a lot of promise with self-service business intelligence. Few issues in other issues would be, it's easy to make a beautiful dashboard. It's hard to make a dashboard that's useful. In this case, we're looking at a junkyard, and we can see the car details. We can see the percentage of projected profit for each vehicle. We can see if there's any high dollar parts still left on the car and how many days it's left in stock. But if you're looking at this and you have all of these different points, you could get kind of analysis paralysis. So the goal is to boil it down into something simple. In this case, we have a formula, a magic formula. It's got details behind it, but it tells you which cars to crush next. And basically that answers the question, which cars are worth more as scrap than they are taking space up on the lot? And another issue, there's other issues in visualizations. Accessibility is huge. The tools can make it easy to handle accessibility, but you have to remember it and pay attention to it. Things like tab order, so that people using the reports, if they're using screen readers or they can't use a mouse or whatever it is, they have to use a keyboard, they can tab from each item on the screen and it goes in a predictable way, not in a random way. Color blindness as well as low vision. These are also issues that report makers need to be aware of. Honesty is huge, but being honest with reports is easy because the tools make it easy. It takes work to start a bar chart at 34% instead of at 0. But as you can see, if you don't start it at 0, it exaggerates the difference between the two data points. This is from Alberto Cairo's How Charts Lie. Other people are Cole Knaflick and Stephen Few. There's a lot of people who write about dashboards and visualization. And finally, clarity and simplicity. Again, this is going to vary depending on your target. But, for example, with accountants, they always want to see the data in excruciating detail. So that's what's most important to them. And the bar charts are almost a distraction at that point. So, and then finally, I do want to talk about imposter syndrome. It's another concern if you're working in a professional field, probably any professional field. It can happen at any point along the career path. So that it can happen when you're starting out. It can happen when you are looking for jobs. It can happen even if you're established. What happens is you kind of get numb to everything that you know. And then you focus too much on everything that there is to know, all the changes that are constantly coming. And so it's just important to know that I know something, you know something, and I can't do everything myself. I have to rely on other people, and other people have to rely on me. And so we have to work together in this. I will say too that, I can do things in Excel that very few people can, but if it came to a mail merge, I would be lost. I haven't done mail merge in many years. Then I want to So that's my presentation. I want to encourage you, if you have an interest, check these things out. Power BI Desktop is a free download from Microsoft. You can get it from the Microsoft Store if your company's on Office 365 even, and install it without tech support. It's that easy. Most cases. There are some cases where it's blocked, but very few. There's a certification course which is excellent, and it's got labs. We did the Ergon Data Science presentation a couple months ago, and that is another great presentation. It has all kinds of details about career paths in the field. And then LinkedIn Learning is offering some career paths through March of 2021. They're doing this to help with the current employment crisis. I've taken both these classes. I finished the first one, and the second one I'm about halfway through. So thank you for your time. Head it back over to Razib, and I'm excited to hear what Elisa has to say.
Thank you, Fred. That was wonderful to share your experience and your take on the business analytics. So now I would ask Elisa to talk about the machine learning aspects of it. And so before Elisa starts, I'd just like to remind everybody that please feel free to write any question that you have for Fred and Elisa in the chat. And then once their presentation is over, we'll have some opportunity for discussion. Okay, Elisa, the floor is yours.
Thank you. Now, before starting, I see a few known faces and names. I just really would like to ask you, since probably we are all at different levels about knowledge of AI, data science, machine learning. How do you feel with that? If you can write in the chat, low level, I don't know anything about it. Medium level, I heard about it. I know more or less what that is. Proficient means high level. I'm great, and I just want to know the cutting edge techniques. So because I think we are all different starting points. So at least this presentation is useful for you. And then the second thing I asked to write in the chat is, what do you expect from this presentation? Because some of you are mentees, some of you are mentors. So what do you think I'm going to what do you want me to do? What do you want me to speak about? What do you expect from my presentation? It will be interactive. So there are a few exercises here and there. It will be interactive. Okay, Lorenzo is proficient. Beginning level, Caro. Okay, I know a bit about it and haven't used it. Okay. The others, Daniel. Okay, Alessandro. Okay. So I will start giving a bit of overview about data science and introducing, even for those that do not know it and do not know anything about it. Hoping to say something also for those that are proficient, like Lorenzo. So this is the agenda. Okay, first of all, I introduce myself. So as Ravi said before, I work as senior consultant end-to-end analytics. I manage projects that actually leverage this kind of techniques for different companies. I worked 3 years in McKinsey in Italy, and then I attended a master at MIT in business analytics. And after this master, I moved in California, Palo Alto, to work on a niche company that is extremely specialized in machine learning. There are 80% of employees that are PhD students from Stanford, MIT, Harvard, this kind of universities. And we've worked for the high-tech companies. So after this brief introduction, the agenda is we are going first to see why machine learning and data science are relevant for companies, so company perspectives. Second, what is data science? Give you a brief overview of it, and how to become proficient in it. So also for mentees that want to develop skills, this will be useful. Use cases and companies perspectives. So this is a very full slide, but what I want to show you here is that there are a lot of applications across different industries, across different functions in a company, from predicting the demand to actually optimizing production. When you, for example, go Amazon sometimes is suggesting you the next product to buy, saying like you bought ABC, why don't you buy D? Okay, this is using machine learning. There is Amazon that the next day delivers to you the product you're going to ask for. I mean, they kind of predict it, and they have it ready for you, or there are companies like, for example, Netflix. I mean, you saw a few movies now. Why don't you see this other movie that probably you liked before because you had a past behavior, a specific past behavior, or like a lot of use cases. Okay, what do companies do is basically they select one of these. They say my problem is probably predicting the demand and trying to understand what's the inventory I need to keep in the warehouse. Or for example, school, I see Carol, so school a problem of the school might be I want to know how many students I will have attending my programs the next year. Okay, so how to predict this, because there is a seasonality. So all these questions can be answered, all these questions about predictions and all this decision making about how do I make a decision that is optimized according to what will happen in the future. All of this is like data science. It can be done through data science. So how do companies tackle this kind of problems? Usually they say, I want a big like digital transformation. But first of all, they start thinking about what could be problems to be solved. Okay. Then they start to prioritize. How do they prioritize? They prioritize according to two dimensions. The first one is how feasible is that? Do I have the data to do that? So connected to what Fred was saying, is extremely important to structure very well the database and the data warehouse, because you need to be ready even for things that you did not expect that you wanted to do. So feasibility. Second dimension is the impact. If I predict demand, I know that I will not miss orders from clients. I know that I will have less inventories. So my revenues will be increasing and my cost of inventories will be decreasing. By how much? You have like estimates, okay? Now, according to these two dimensions, you will position different problems that you could solve through machine learning, and you start from those with a high feasibility, high impact.
I think Elisa's internet connection is probably acting up. We'll just give her a minute.
Do you see me? Okay.
Yes. Yes.
I will start sharing this again.
Okay.
So, okay. So basically, the idea here is there is a timeline. So the companies start to tackle problems one by one according to prioritization. There is a timeline. First of all, there are stages. At the very beginning, there is a readiness assessment. So it's extremely important to understand if we have the data to do that. What are the measurements we want to be improved? So accuracy in some forecasts, revenues, costs. And then there is a pilot. So I developed the model, and we'll see later how, with a limited number of products for a limited number of customers, whatever. And then once I see it's working in a limited scope, I send it to the rest of the company. Now, who is delivering it in companies? And I think this is important for mentees when they look for jobs. Usually, teams are cross-functional. Okay, I mean, one project like this needs to be done by people that have different skills. First of all, there is the data translator. So data translator is the one that understands the business, understands more or less what can be done with machine learning, and defines priorities, and define like what kind of model to use together with the data scientist. Then after we have visualizations that Fred showed us, visualizations, they need to understand how to translate the results into decisions. Okay, so these kind of roles are in between the data scientist and the managers, the top managers of a business. Then there is a second figure that is like the second role, that is data scientist. Data scientist is the expert of models, as we'll see later. He knows what model can be developed. He knows how to improve the performances of models. And then data engineers. Data engineers is the one, does exactly what Fred said before. So it needs to pull together all this data. The format of the data needs to be standardized. They need to know what kind of structure in the database to use in order to make it flexible for problems that you might solve, but you still don't know that you have to solve. But like, you need to make it flexible, scalable. Okay, and they need to work all together in order to deliver a project to deliver impact by leveraging machine learning. Now that we saw why this is important for companies, how companies more or less can leverage it in terms of timeline, in terms of team structure, what is data science? Okay, sometimes it's a black box. I want my objective today is to just not make it a black box anymore for you. So you will understand what data scientist is once forever. So first of all, there are 3 stages where data scientists create value. So first of all, descriptive. What did happen? Second, prescriptive. What will happen? And third, prescriptive. How do I choose what to do according to what I predicted about the future? So we will focus today on predictive. So how to predict what will happen. Now, what is great about machine learning is that it understands hidden patterns in a complex reality. So just look at this like figure with greens and reds. There are things happening. It's very confusing how they are ordered. Okay, and we want to understand, we want to detect these red spots. What traditional statistics does is that they start from a model. They say, I don't know, the higher is, for example, the person, the higher is the height, the weight, the higher is the height, or the higher is the height, the higher is the weight. This is a model. Okay, this is an hypothesis. They start from this model in order to predict, for example, the weight. You can start from a basic model saying, okay, first of all, the model that I have in my head is that if the height increases, the weight increases as well. So it's my model, okay? And I want to understand how, by how much. by fitting this model through the data. So just looking at reality, but I have an hypothesis on what does grow by growing what, okay? And machine learning does not need an hypothesis. Machine learning looks at reality and detects by itself patterns. How, this is an exercise to do together. When people ask me what machine learning is, in order to make it no more a black box, I always use this example. That is, here we have a table with different rows. Each row is a flight. Now let's take this first row. This row represents a flight that took off in the season like fall. 1 is yes, 0 is no. So in a rainy day, yes, in a rainy day. In a cloudy day, yes, in a cloudy day. The hour of the day took off at 6 p.m. with American Airlines from New York city departure to Chicago city arrival, and the flight delayed. Now here there are different flights. So the second one is like took off in fall, no rainy day, no cloudy day, 6 p.m. American Airlines from Boston to Detroit was delaying, okay, and so on. Now, the question for the machine learning model is, how do I know, I mean, does my flight delay? Is my flight gonna be late? This is a question for my machine learning model. Please, machine learning model, tell me if my flight tomorrow morning, I give you all its characteristics. If the flight of tomorrow morning is gonna be late. The machine learning model gives you an output on an Excel saying it's gonna be late. No, it's not gonna be late. So the machine learning model answers to this question. How does it do it? It takes an input. It looks like it takes an input. Like there is a code you can say read this table. Simple. A table like this, and it starts to understand what are the characteristics that delayed flights have in common. So if we do this together and I ask you what are the characteristics that delayed flights have in common, what would you answer? You can answer me in the chat. Let's see if there is someone that guesses it. Okay, American Airlines New York evening, and then it delays. Christian says American Airlines, correct. American Airlines delay, New York, an evening. Okay, I imagine it's the intersection of the three. Like you're saying, Christian, I imagine if it's American Airlines and it's evening and it's from New York, then it delays. And rain, combination of the three. Like you're saying, it's rainy and afternoon and American Airlines and from New York. Okay, rainy afternoon, American Airlines New York, there are only the first row and the third row that respect all these conditions you're writing in the chat. Is there someone else, like someone else that has a guess? So rainy day, going to Chicago in the afternoon, Giusy. Rainy day, okay, we have first, third, fourth. Chicago, okay. In the afternoon. Okay. That respects, Giusy, that respects all these characteristics. There are only the first and the third flight. Alessandra says American Airlines, okay, there are the first three, and then the last, like the 6th one, and then 6 p.m. So the first three that satisfy all these conditions. Okay, I think we started to get okay something. I will just say that you spotted afternoon. Okay, afternoon is a great indicator, even like American airline. Why is that? Because afternoon, whenever it's afternoon, it's always late. You see, whenever it's afternoon, it's always late. Now there is this fourth flight that we need to like split from the last three somehow, because this fourth is morning instead, but it's still late. So if it's afternoon, it's always late. If it's morning, we need to look at the rain. Because if it's morning, we are the last 4 rows. And then what's the difference between this flight delay in the morning and the other 3? That it's raining. So if it's afternoon, it's always late. If it's morning, I need to look at the rain. If it's morning and raining, then it's late. If it's morning with no rain, then it's not late. Okay. We built a machine learning model, basically. This is a machine learning model, and it's actually a tree, and it's the simplest machine learning model ever. But the others are mostly variations of it. So the machine learning model is represented with these 3, saying if it's hour of the day higher than 7 a.m., yes, then 100% delay, as we said. If it's no, then it's morning. If it's no higher than 7 a.m., it's 7 a.m. Then 25% of rain, but 25% of delay. But if we look at rain, so if it's morning and it's rainy, then there is a delay. If it's morning, no raining, there is no delay. As we said, like, this is just a representation of what we said before. Now, is the model good in order to predict the future? Because now it's just descriptive. We said descriptive, predictive, prescriptive. Now it's just describing what happened. It didn't do anything more than that. How do we know if it's also good in prediction? We take 3 flights that were not used in order to build the model. Okay. And these 3 flights have these characteristics. So the first one, fall, rainy day, hour of the day afternoon, and then flight delay. Second one, flight, I mean, so what the machine learning model does is, sorry, again, we take these 3 flights that were not used to build the model. We need to see if the model, we need to compare reality with what the model would have predicted. So what would the model have predicted considering the first flight? First flight is, we need to follow these 3. So is hour of the day higher than 7 a.m. for the first flight? Yes, it's higher than 7 a.m. because it's 6 p.m. So I answer yes. The model predicts a delay. And actually in the data, I need to compare the data. So these are hidden to the model. These 3 numbers are hidden to the model. Actually, it delayed. It was late. Now, second is a model correct, great model. Now, second row, again, is the hour of the day higher than 7 a.m.? Actually, it is 7 a.m. So I need to answer no to this question. Then I need to check the rain. It's no raining, so I need to go right again. So the model predicts no delay, and in fact, there was no delay. Third row, hour of the day, higher than 7 a.m.? No, it's 7 a.m. I go right. I need to check the rain. The rain here is no raining, so I go right again. There is no delay predicted by the model. Actually, in the data, there was a delay. The last one was late. So here the model is not correct. So the model has a 60% model accuracy. So it's correct 2 times out of 3. Okay. And usually model accuracy is around 80% for a good model. I mean, it depends on the industries, it depends on like how the data, I mean, the accuracy of the data themselves, but it's usually 80%. Now, this is one tree, so the simplest machine learning model ever, okay? But actually, machine learning is a bit more complex than this, but not too much. There are models that are called random forest. So this is one tree. Random forest, what would you mean? What does it mean? What would you guess? A random forest, so like a random set of trees. Okay, yeah, great. So there are a lot of trees reproduced by the machine learning, all put together. So like a lot of trees produced with different set of past data, and then like the guess, so the prediction is just the average guess of each tree, the average prediction of each tree. Or there is gradient boosting. Gradient boosting is where a tree learns, corrects the errors of the previous one. So I produce different trees, one after the other one, and like the following trees are more focused in correcting the errors of the previous one. So this is gradient boosting. These are like models that are widely used in industry, like gradient boosting, random forest. I'm not speaking about like things of elementary school. I mean, I mean, these are things that managers use every day. So and go on and just want to give you a brief overview of a few like definitions of AI, machine learning, all these kind of things. So what we saw is this tree. You recognize it, okay? This is within a class of supervised learning. Supervised learning is basically used to for predictions, as we said before, and you have something to be predicted. Okay, sometimes like we have images, we want to recognize images, we want to predict if an image that the machine never saw before is, in this case, a cat or a dog, in this case of this image, right? So I give to the machine learning model, in this case named neural network or deep learning, millions of images of cats, millions of images of dogs, and then I say this is a cat, this is a cat, this is a cat, this is a dog, this is a dog, and it's trying to understanding what are the commonalities among cats, what are commonalities among dogs, and this is what Facebook uses when it suggests you if a person, it sees the face, if a person is exactly that person, like I say, I recognize your there is this machine learning behind my Facebook, so that Facebook suggests you people to tag on pictures, or maybe like where the iPhone is creating you videos with collections of stories with people similar faces, like people of the same people, because it recognizes similarities among faces. Now, machine learning machines need millions of images, while kids, it's enough that they see one cat and they can recognize all the other cats, even if they saw one. So at MIT, a lot of researchers are freaking out with this thing. So why a kid recognizes all the cats, given he saw one cat, and I need to give to machine millions of cats in order to recognize cats. And then there are other techniques. So reinforcement learning, robots that are learning, trial and error, like just interacting with space around them through trial and error, and then some supervised learning, just grouping together similar things. I'm going very fast now because we are late. Okay, how to become proficient. This is the Bible of all the data scientists ever. If you go from statistics to data science, this is the book to learn. Now, I will text you. I will share these slides anyway. Now, as I entered in McKinsey, a colleague told me, this is the map, this is a skill set of a data scientist. Data scientist needs to know all of these things. So each one of them is each row, each line that you read here, it's a skill. It's not possible a person knows all of it. So there is this impostor syndrome, like Fred was knowing before. I just know a little bit of it. I don't know all of it, but it's impossible to know all of it because it's a team that needs to tackle a problem. And then, super important, data scientist never stops learning, practice and theory. Kaggle competitions, online courses, on the job, and that's it.
Wonderful, thank you, Elisa. I think that was that was really intense, and that was really a very good introduction to the machine learning in the business settings. So I would like to open the floor for questions from people. Yeah, so the slides, I mean, as Elisa
Yes,
pointed
right.
out, the slides will be available offline. So we will email you the slides. If you have registered through our Eventbrite page, then look for an email from us at the end of this. Okay, so let's see. I mean, while people are trying to have their questions, so one thing, Elisa, and also Fred, is that like, what is your experience, in your experience, like, how do you see this both business analytics and machine learning, like how pervasive it will be in looking forward, like 2 years, 5 years down the road?
Depends on the industry, in the sense that there are industries that are faster than others. In this industry of retail, you need to have it. Nowadays, it's becoming more and more a competitive advantage. And there are these figure like chief data officer in companies, just because this is becoming very important. There are though industries like chemical, like bit slower, that are introducing it now, like those that are the biggest company are introducing it now. It depends on the size of the company, but the biggest companies across all the industries are already adopting machine learning.
Yeah, absolutely. I think that if a company was doing business intelligence 5 or 10 years ago, they're getting into machine learning now. If they weren't doing that much, they're definitely getting into analytics. Analytics is, even if a company's not using it that much, it's something that pays off immediately. So, so I just expect to see a lot of growth in the industry.
Okay, so then, so from your experience, let's say somebody who is in any of this industry, and they're saying their industry is gradually gearing towards using more AI, using more machine learning, and that somebody maybe they're afraid of programming, or they're afraid because they never had that exposure. So what advice would you give them?
If I may say about my experience, so I started programming in 2015 because basically I was working on a master thesis at MIT. I didn't know I was supposed to write any program on Python on R, so I said yes to this professor. Asked me to go and do research with him. He was aware I was not able to write a line of code because I was coming from industrial engineering but with no background on this. And he just started to give me books and codes that someone wrote and like someone else wrote, just asking me to start and learning by myself. Because we need to deliver a project for Converse and we needed to to write an article. I mean, like, yeah, it's basically like in 2 months, I was able to write a machine learning model. 2-3 months, I was able to learn how to write a machine learning model, starting from that book that I gave you. Like, yeah, an introduction to statistical learning. So, yeah.
You also mentioned that this is you're using cross-functional teams, and cross-functional teams means that there are jobs for everybody in this development, in this sense. Industry knowledge and so forth, as part of a team doing something.
Okay, so we have some questions from the participants. So I think somebody was asking, okay, so do you need a graduate degree in statistics or machine learning to enter a career in data science? No.
No.
Okay.
I've done it with just some, yeah, a research thesis, master thesis on this kind of topics. But just because I found a professor that exactly like what I said before asked me these kind of things, and I learned by myself. And a lot of people I hired in McKinsey, because then in McKinsey they asked me to start from the ground up a team of data scientists. So I started to hire data scientists for McKinsey in Italy. They are 15, and nobody of them graduated from business analytics or masters that are similar. But all of them were so curious about it. They went in Kaggle, started to see competitions, started to participate in competitions, started to write code by themselves, reading books, all these kind of things. So it's not needed. You can do it by yourself with the right material.
Okay, there's another question for you, Elisa, is that would you spend a few words about the current job market related to AI? I think we have covered this, but sure, yeah.
Very briefly, what I'm doing is that I'm going to companies that say they need machine learning somehow. They don't know how, they don't know what that is. So I start to understand like their business model, what they do, how to operate. And I start to try to understand if the classical business problems like forecasting of demand, like all these kind of things actually could be something that they need to solve given the situation they have. So once I understand what's the priority for them in terms of feasibility and impact, then I propose a timeline of a project like the one you saw. I size the team that I need in order to deliver it. I sell the project. After I sell the project, I need to deliver it. So I ask a company to give me like a couple of junior people, and then I start to define plans in order to deliver projects. And I start coordinating the entire project with the client in order to make sure that the client is satisfied, and then like integrate at the end solution with the client systems, and basically we start making business decisions according to the output that they see. So I follow them a little bit after. I train them to use whatever we developed, and then like they have an increase in revenues or decrease in costs, and I'm going to measure that. And then like if they're happy, they start with another project. But in the parallel, I speak with other companies in order to see if other companies need the same thing.
Okay, thank you, Elisa. So I think we have one last question and then we have to wrap up. So I am just going a little bit over time because this seems a little bit important. So somebody said, so they have taken a sabbatical and they have a degree in computer science, but while raising family, they have taken a sabbatical. Now they'd like to know what is the starting point to get into the game.
Okay, what is the starting point? Again, I believe is that book. I have a bachelor in, okay, I'm lost in this question. I have a bachelor in computer science, okay. Trying to start again. I really like things that it's important to, yeah, Tableau, yes, Tableau is easy though. I mean, I think it's important to start having some proficiency with Python. But like it's also important to understand. I mean, it's not necessarily important in order to enter in this data scientist field. It's not necessarily important to write code. I mean, I'm not writing code since 3 years, so it's important to let's say. I mean, we can have this conversation separately because I'm doing all this kind of work with my mentee exactly on this. So you can write me separately. My email is Elisa. I mean, the email that I read the most is Elisa at. I write it here. Sorry. I mean, I write it here down. Okay, this email I use the most. So if you have questions for me like this one that are very specific, just write me privately.
Great. So yes, if you have questions that Lisa or Fred can answer, please.
There is this one of Alessandro. I will be very fast in answering to this one. Could you give me a sense of how sophisticated this demand forecasting models are for big firms? Do they use only internal data? They also look at external data. Okay. They usually use both. I mean, it really depends. It really depends because if they're starting from mod, I mean, they're starting from like predicting demand with average, mean average of the last period. I mean, sorry. The important thing is to increase the accuracy according to the baseline you have today. You want to do better than today. Now, if they're already doing good, then you need to get external data, internal data, and make it sophisticated. If they are not using machine learning at all, you just start from internal data. And this is what big companies are doing as well. Like they just want to improve the baseline.
Great. Okay. Thank you, Elisa. So, I mean, as Elisa pointed out, so feel free to ask any question that you have for Elisa and Fred. Their email address is there, and I will email you the slides as well as their contact information again, just for your benefit. So, okay, so unfortunately, we have to wrap up our today's proceeding. Thank you, Elisa. Thank you, Fred, for this wonderful presentations. And I think this was very informative. And look forward to seeing many of you in the next Aragon seminar. So until then, be safe, be well. Take care. Bye-bye.
Thank you for the invitation. Bye-bye. Thank you.